Hi, Leo Dreger here. I want to talk about md5sum. md5sum is a very, very easy utility to use, and what I find surprisingly about this is not a lot of people know how to do it. It's a very easy utility to run. Anybody should be able to go to the internet and download it. So to get the tool to begin with, either you could have it from one of your forensics hacking kits or something like that, toolkit of some sort, or just Google md5sum. Okay, the one that I've routinely always gone to and for years and years and years is the one from eTree. eTree has been around. It's been a project that's been around for years and years and years, and they have an md5sum.exe that is real easy to get right here on their website. I know it. I trust it. Easy download, reliable, every time, all the time. So once you install it or download it, what I've actually done is I just like to copy it to the root of my hard drive. So you can see here I have the MD5 utility right here. Okay, right here. So what we're going to do is open up the command prompt and use the utility. Okay, so let's open up the command prompt. Okay, we're going to clear the screen. And we're going to need a file to analyze. So let's do a notepad, password.txt. Okay, and you can see I've got a password file in here. And what I'll do is I'll just simplify this at first, and I'll just put the word password in here. I'll save the file, and we'll just minimize it for now. Okay, so it's md5sum. And I like to tab my way through it, space password.txt. And here is the message digest. So what these integrity algorithms do is they analyze this file without changing, modifying, or altering it. It's just an algorithm that kind of passively analyzes it and then gives you the output. Now what's interesting about this message digest is if I copy that and then go over here to Google, okay, and then just put the hash inside of Google and then hit search, you can see that something as simple as password is easily indexable by Google. Now, when I'm in class, I always ask the students, well, how did Google find it? Did it reverse it? Did it find the trapdoor? Did it decrypt it? What exactly happened here? And the class always kind of scratches their head and think, well, wait a second, how did it find it? So all Google did realistically was find a reference to somebody else having a file with the same exact context in it, and then also the reference of the hash, and then Google just referenced that. Google didn't do anything to this file. But nonetheless, you can see that, for all of these different password options, there's already previously defined values for the word password. Okay, so that's a very, very, very common one, to say the least, as you might suspect, considering it's the word password. So it's easily indexable, and we'll come back to that later, because when I show you a harder version, or when I salt it, I'll show you that it pretty much defeats this type of attack right away. Okay, all right, so let's just run the algorithm again and prove that it hasn't changed. Now, I can do this literally 100 times here. It is not going to change, okay, if I use the right command. And for this lab, you guys can just pay attention to the last 2 digits of this file, okay? So if I open up this file and take the word password and I add 1 space to it, this little space right here, what's going to happen if I run the integrity algorithm again? Is it going to end in 99? Is it going to be something different? What's going to happen? And if you're thinking it's going to be changed, well, let's get the right command. Here we go, md5sum. It's exactly the same because I didn't change the file. Okay, so you still have to actually save the file. So I like to actually prove that. Now that I've actually, I got you, So now that I've actually saved the file, if I do it again, you can see now that it ends in 7.5. And I could take this right back over to Google. I just highlight this, hit enter, go back over to Google, put my pasted value in here, search for that. It should still find this, no problem. And it's just the password with a space to it. And as a matter of fact, it actually finds it with SHA and things like that as well too. All right, so still not hard at all. Okay. Now, one of the tricks to this is if we actually go back to the word password and take out this space, file, save, so no tricks this time, right? Now what's going to happen? Is it going to end in 99? Is it going to end in 75? Or am I going to get something different? You guys decide. You vote. I'll give you a second to think about it. All right, got your answer? So md5sum password.txt, it goes back to 99. I'd say a good half of the class, about 95% of the class always says, well, it's not going to be 75. But good 3/4 of the class, almost 90% of the class, generally chooses something different. But it actually goes back to 99. And this is important to realize when we start talking about the state of integrity, because integrity is just a snapshot in time. And in this case, what I've done is I've taken a file, I've moved away from that file, so I have made changes, modifications, and alterations. Notice I did not say encrypted, decrypting, ciphering, substitution, transposition, permutation. I didn't say any of that. What I did say is change, modify, and alter. Change, modify, and alter have to do with the principles of integrity: encrypt, decrypt, transpose, substitute, all that stuff has to deal with confidentiality. We're talking about integrity here. Okay, which is critical in the beginning part of forensics, because we don't want to change the integrity of our files, folders, and hard drives. Okay, so it actually changes it back to 99. Okay, so then people start going, well, what happens if you do things like a trib? Okay, what if I do a trib to password.txt? Right, you can see what attributes are set to it. If I go to the hard drive and grab my password.txt file and look at the properties, now I did change the timestamps to it, but the MD5 utility doesn't necessarily, the md5sum utility itself doesn't care about any of this stuff. It only cares about the data of the file or the contents of the file. It doesn't care about created, modified, access, read-only, hidden, any of the advanced options here, the name of the file, any of the security permissions could have been changed. Anything over here could have been added. You could have went and advanced over here. None of that matters specifically in md5sum. What is interesting is that if you compare that on a Linux platform and you use another hashing algorithm, other platforms may include some of those attributes or things like that. But specifically in Windows, md5sum does not. Okay, so you can see that it basically goes back to the original because it doesn't take that into consideration. So now what we can talk about is, what do these values mean? Now, I pretty much crack the word password in this file because I can easily find a reference to what the hash is. But how do I defeat this? Well, let's talk about the power of salting. Salting is basically another file that is added typically on Unix systems or Solaris systems or any system that supports salt. But it adds this prefix, which is just random numbers and letters to the beginning of the password file, and then pretty much your password. So it now has two components. It's got the original value, plus it's got this random prefix to those. Now, as you may have guessed, now if I do an md5sum to the password file after saving it, I get something completely different. But if I copy this value here and then just go to try to find a quick match to it using, our favorite oracle of choice here, and search for that, it's going to come up null. It's not going to be able to do it. So I know it's not exactly the same, but on a brief sanity check, I'm basically defeating, dictionary-based attacks or rainbow table-based attacks. Not necessarily dictionary, more rainbow, because rainbow is more hashing, dictionary is more trying to decrypt, more cryptography, more confidentiality. Or by matching a list. This is specifically trying to find a reference. All right. So I can prove that I don't get an easy one. All right. And just to kind of build upon this, just to make this this lab, really, really interesting, I want to prove one other thing here. I want to search for online. Let's get my mouse back. Online hashing calculator. Okay. And I really like this one, fileformat.info. It's normally the first one that comes up if you search for online hashing calculator. Right. So you click on that. Give it a second to load. Once it loads, we can put some text right here. I gotta wait for the web page to finish loading. It's still loading the components of it. You can tell because it's actually scrolling down here. I'll just give it a second. It's probably on your system going to work a lot faster than this. All right, here we go. So if I just take my text string in here and do password, if I just put in my password function here and then select hash, you will see that it basically just runs hash question mark text equals password. And then just go ahead and scroll down and look at your results. What's really, really cool about this tool is it'll tell you the value of the data in the form of the hash through just about every major hashing algorithm out there that you would need to know in the results. Right, so it tells you your original text, it tells you what the original bytes look like in hex, it runs it through Adler 32, gives you the value, runs it through cyclic redundancy check 32, gives you the value, runs it through Haval, which we commonly talk about in CISSP classes. It talks about MD2, 4, and 5. Here's the value of 5. Look familiar? Ends in 99, and it proves that all of these are 128 bits or 32 characters. Here's your ripe 128 and 160. Notice 160 is a little longer. SHA and the respective size of SHA. So here's 160, here's 256, here's 384, and here's 512. It tells you in Tiger and it tells you in Whirlpool. Okay, so what I like about this is it just tells you all of them right away, and that's basically what a hashing calculator does. And you could just put in some text here, or you can upload a file, and the website works pretty well. All right, so the only thing that I'm proving, in summary, the only thing I'm proving is that password, now specifically referenced to what we're doing, ends in 99. So I supplied the data, password, it supplied the hashing algorithm, and we got the same exact results every single time. So that's very, very important in the fundamentals to understand. The MD5 algorithm has to work exactly the same for the data every single time, all the time, no exceptions. Because if I send some data to you, you need to be able to verify that data no matter where you are. As long as we use the same algorithm, we will get the same results. Okay, so let's go back over to password and let's take out these values here, save the file, Run the algorithm one last time, and you can see it goes back to 99. Okay, so this lab is one of my classic, most famous MD5 labs that I exist for mastering the concepts of integrity. Please remember, in the world of confidentiality, you do want to change. You want to change plain text in the ciphertext. In the world of integrity, you do not want to change. You cannot change. It should make sense that, you know, if we were analyzing a file here and we were changing it in the process of analyzing it to prove that it hasn't been changed, but every time we're analyzing it, it's changing it, how could anybody ever verify that it's never been changed, right? So what this algorithm has to do, is never change your file, okay? That is the sole principle of integrity. It's the lack of change that we're detecting here. Or when was it changed? We need to be able to detect that. When we changed it here and it ended in 7.5, it changed. We detected that. When it always stayed 99, like if I just keep doing it right now, well, not that. If I just keep doing it right now, over and over again, okay, it's going to be 99 1,000 times if I do it. So I'm proving nothing has been changed, modified, altered, nothing has been added, nothing has been subtracted. The algorithms are going to be consistent, which is what we want, every single time, all the time. So I hope this helps separate in your head the pure differences from a principled point of view, the differences between confidentiality and integrity. This lab is so powerful in the fundamentals of, one, cryptography, and two, a lot of these certifications that you're going to go after, because when they ask about the differences between confidentiality and integrity, most people just can't simply understand the difference between confidentiality and integrity. They can talk about them, but they don't know how to back up their talking technically. So what I want you to do is try some hands-on labs with integrity and then some of the confidentiality tools, and see that in the confidentiality world, we do change plain text in the ciphertext. We run it through transposition, substitutions, permutations. We take out, replace. But in the world of integrity, we do not. And it's just that simple. My name's Leo Dreger. Thank you for watching. Don't forget to check us out on Facebook, LinkedIn, YouTube, and Twitter.